Start with the syllabus on the electron. So there's the entire syllabus that relates to the chapter on the electron, which is chapter 29, and it's the first two sections that we're going to do, or we're going to have finished today. In other words, you should know that the electron is an indivisible quantity of charge. You should know its mass's location. You should know the units of energy for an electron are so small that we use a different quantity called the electron volt. And we can have electron volts, kilo electron volts, mega electron volts, and giga electron volts, which are 10 to the power 3, 10 to the power 6, 10 to the power 9 respectively. You should know who named it, who came up with the quantity of charge. And then number two, thermionic emissions. So what are they? Cathode ray tubes. The cathode rays can be deflected in an electric and magnetic field, and you should also know the applications of them there. Okay, so let's get into it. So a recap of cathode ray tubes and thermionic emissions. First off, anyway, thermionic emissions, the emission of an electron from the surface of a hot metal. It's a definition, you just need to learn it. The cathode ray tube, the diagram looks like this, and here's how it works. On the left-hand side, there's a heating filament, and that heats the cathode, causes thermionic emissions to occur at the cathode. The electrons are then accelerated across the screen by the high voltage between the cathode and the anode. Now the X and the Y plates will control the position where the electron hits the screen, and then finally the electron will convert its kinetic energy to light as it hits the screen. So that's how the thing works. Right, you had these questions for homework. So 7. The diagram shows a simple cathode ray tube. Name parts A, B and C. A is a heating filament, B is a cathode, C is an anode. Electrons are emitted from A, accelerated across. Explain how they are emitted from A. So it's just thermionic emissions, that will do, which are the emission of electrons from the surface of a hot metal. Question 8 is, part 1 is a repeat of 7, part 1. So give any function of these two parts for question 8. The heating filament heats the cathode, that's the first one. The cathode is where the electrons are emitted from, so it's where thermionic emissions occur, that's B. C is the anode is used to accelerate the electrons, and D is the fluorescent screen. It fluoresces when electrons strike it. Question 9, why is there a high voltage between A and B? It's to accelerate the electrons. Okay, the uses, I leave you finish yourselves. How are the electrons accelerated across it in a cathode ray tube? By the high voltage. And then what happens when the electrons hit the screen? Their kinetic energy is converted to light energy. Okay, the energy conversion. Now we're just going to look at one energy conversion here, and that's the conversion of electrical energy to kinetic energy. So what that means is the electrical energy in the system will equal the kinetic energy of the electron if the energy conversion is 100% efficient. If we put formula in there, we know electrical energy is QV, kinetic energy 1/2 mv squared, where big V is the voltage, little v is the speed, and then we have Q for the charge, M for the mass. Okay, one calculation, and then I'll give you guys a calculation. You can pause the video. So we have a high voltage of 3 kilovolts applied across a cathode ray tube. We're asked to calculate the energy given to the electrons. So that energy is electrical energy. We can use that formula. If we fill in the charge on the electron, because it's electrons being accelerated, and the voltage of 3000 volts, multiply the two of those together, and we get that value in joules. Now part 2 of the question says calculate the speed of the electrons as they hit the screen. So we're going to assume that that amount of electrical energy will be converted to kinetic energy. So the electrical energy is equal to the kinetic energy. The kinetic energy formula is 1/2 mv squared. It's an electron, so put in the mass of the electron, and then work out or calculate V, and you might just check that for me, at 3.2 by 10 to the power 7 meters per second. Now, if you guys go to the notes and do question 14, you can pause the video here, but I'm going to keep going. Right, some things that you need to remember about cathode rays. So they're beams of high-speed electrons, and if they're electrons, they do the following. So number one, starting from the third one, they can be deflected in an electric and magnetic field because they're charged particles. If they're beams of high-speed electrons, we know from cathode ray tubes, they travel from the cathode in a straight line because they're focused by the anode. And we also know in a cathode ray tube they cause certain substances to fluoresce. And what we haven't done yet is X-rays, so we're going to skip over that for now. Okay, the electron volt. Well, the electron volt is just a new unit of energy. It's the energy of an electron that the electron gains when it's accelerated through a potential difference of 1 volt. Now what that means is we can use QV. The charge is the charge on the electron, and if the voltage is 1 volt, it means that our electrical energy volt, or our electrical energy in the new unit, the electron volt, can be calculated from that. And what that means is 1 electron volt is equivalent to 1.6 by 10 to the minus 19 joules. We use this just because the energy is really, really small when you're talking about electrons. So it gives you nice whole numbers and nice manageable figures in electron volts. And what you need to remember is when you're converting from electron volts, you multiply by the charge on the electron. So that's 1.6 by 10 to the minus 19 for now, but go to the log tables for the actual value for that charge on the electron value. Okay, there's your homework. Will you make sure you've got 1 to 14 finished?